In this video, we will show you how to integrate the brain-computer interface into a Unity game. First of all, you have to create a new Unity project. I select the 3D project for this example. Before starting with the actual game development, we have to apply some settings. Click the Game tab and ensure that VSync is enabled. VSync ensures that the BCI can be synchronized with the computer display properly. Afterwards, you can click Assets, Import Package or Custom Package. Select the Unicorn ERP Unity interface. Unity Package. The Import dialog should be displayed. Ensure that all of the items included in the package are selected. Then, click Import. All the images, scripts, and libraries should be imported into your Unity project now. Open the Prefabs folder. You should find a BCI Manager prefab for 2D and for 3D projects there. Select the BCI Manager for 3D projects and drag it into your scene. You can see that the license key has not been activated yet. Open the Unicorn Hybrid Black and go to the Licenses tab. Click Add to activate a license key. Enter the license information received via email after purchasing the Unicorn Unity interface from the web shop. The Unicorn Unity Hybrid Black license should be listed as installed license now. Close the Unicorn suite. As you can see, the license activation has not been updated in Unity yet. Update the license by clicking the play button. The license warning should disappear now. You should see the BCI settings, as well as a dialog for training and application objects. To implement a BCI, you will need a training phase, where the system is adapted to your individual brain signals, and an application phase where you can control the game with your brain signals. This Unity interface implements a visual paradigm. Therefore, you need some flashing objects to present the visual stimuli. You will have one training object and you can have multiple application objects. If you want to create a training object for the BCI Manager 3D, you simply should add a new 3D object to your scene. Rename it to Training Object. Repeat the previous step for your application objects. Here, we chose to use 6 objects for our application. For that reason, we added 6 application objects to our scene. In the image folder that has been added to this project, you already have some dark and flash textures. Add one of the predefined textures to your training and application object as the sprite. Training and application objects have to be connected with the BCI Manager 3D for creating them. You can rearrange and reposition your training and application objects now. Just drag and drop them according to your desire. Ensure that the number of classes is set to at least 6 classes in the BCI settings. Set the class ID to 1 for your training object. Add the training object as game object. Select a flash image and a dark image. You can create your own images and add them here too. Now, you can connect and configure the application objects. Click the plus symbol to add a new application object. Set the class ID to a number between 1 and your configured number of classes, in this case 6. Add the application object as game object. Select a flash image and a dark image. Repeat this step 5 times for all your application objects. Each game object and class ID should be used only once. The BCI is configured properly now. Training and application objects have been connected with the controller. As a final result, you have to decide what to do when you select some items with the BCI. you will find a script called class selection available.cs in your assets folder. This is an example script listening to the classification results from the BCI. There are 6 classes in the BCI manager. Therefore, you will get a number in between 1 to 6 whenever you focus on the corresponding application object. If 0 is returned, the BCI was not able to clearly identify an object. This should mainly be the case if you're not watching the screen or if you are not focusing. Add the class selection available.cs to the BCI Manager 2D. This example shows how to use the BCI classification results. We show how to use the BCI classification result and give the user some feedback on which icon he or she is focusing. We add a new game object to every application object and name it selected. These objects should be hidden afterwards and only be visible if you're focusing on the corresponding application object. Now, we want to add some logic in the script to achieve the described behavior. First of all, we add the ERP Flash Controller 3D as a public member to the script. We will get the application objects from this script afterwards. Now, we are adding a dictionary to store class IDs and sprite renderers. This dictionary will store the class ID and the selected objects. We have to initialize the dictionary. Then we loop through all the application objects contained in the ERP Flash Controller, which are our application objects, since the selected was added as a child of the application object. We scan the children of each application object and store the selected objects as well as the class ID. Now, we disable all selected objects by default because we want to enable them with the BCI afterwards. Link the ERP Flash Controller 3D to the class selection available script. If we hit play now, all the selected objects should disappear. Now, we have to link the BCI classification result with the selected objects. The BCI returns a number between 1 and number of classes, in our case 6, if you are focusing on an application object. If you are not focusing or looking at the display, 0 is returned. These values are received via the onClass selection available event and are continuously updated. In the update loop, we already have a predefined switch case statement where we can add some code for different class selections. For our application, we remove this statement because we want to perform the same action for every selected class. We want to disable all selected objects to clear previous selections with each iteration. For every other class selection except 0, we want to show the corresponding selected objects that we already have stored in the dictionary beforehand. All of the coding should be done now. We can try the application now. Click the play button to start the application. Select your device and click Connect. Press Start Flashing to start the training paradigm. The training is finished after approximately 1 minute. You can retrain the system if you didn't achieve a good classifier. We are trying to select one application object from left to right, one by one. Click Continue. If we programmed our scripts correctly, the selected object will be highlighted.